Our last way to combine functions is to put one function inside of another. We write that as f with an open circle and then a g, and either way we read it as f of g of x. So we'll talk about how to find the domain in a minute. So here, and the order of the letters makes a difference. Here it says find f of g of x. So I like to write it in this format because it's easier for me to see. This is telling me that g of x is inside f of x. So I start by taking f, and I would write 2 over, and where there's an x, I'm going to put parentheses, minus 1. F is the first part of my function, so that's where I start. I write the f, but where there's an x, I'm going to leave empty parentheses. And in that empty parentheses, I'm going to put g. So I'm putting g of x in here. Okay, and we'll come back in a second and simplify that. Let's talk about the domain. To do the domain, we have to deal with g of x, which is inside first. And that's what this box is kind of telling us. But if we look at g of x, it's a fraction. And we know that fractions can't have 0 in the denominator. So we would realize that where that becomes a problem is at 0 this time. So we would think about our number line, cross out 0, we'd want everything to the left and everything to the right. So that's the first part of our domain. The second part of our domain happens with this this fraction over here that we're dealing with. So in this fraction, the one that we're trying to find, we need to look at that denominator. So that would be 3 over x minus 1 and find out where it's equal to 0. So the first thing we do is add 1 to both sides, and that gives us 3 over x equals 1. And then we'd want to multiply both sides by x so that it cancels out over here. And that tells us that 3 is equal to x. So this fraction messes up when x is 3. So that means we have to go back to this graph right here, and we have to put 3 on it, and we want to cross out 3 also. So now we want the numbers to the left of 0, between 0 and 3, and greater than 3. So that means our domain would be negative infinity to 0, 0 to 3, and then 3 to infinity with u's between each of those pieces. Now we can go back and we can simplify this fraction. There's a denominator of x in this little fraction here, so we'd want to multiply this by x, multiply this by x, and multiply this by x to get rid of that fraction, like we did back in chapter 1. So here it cancels out. On the top I just have 2x. Here it cancels out, leaving me with just 3. And here 1 times x is just x. So this is our final composition of functions. Let's look at another one. So here it says f of g of x. Again. So f comes first. That means I look at f first and I write f, but where there's an x I'm going to put parentheses. And in those parentheses, the inside of this says g. So in those parentheses I'm going to put g. So let's find our domain first. In our domain, we want to look at just g of x because that's inside first. So 2 over x. This works a lot the same as the last time. tells us that x can't be 0. Okay, that's what that line through the equal sign means. It can't be 0. So we'd have 0 on our number line crossed out. And then we need to look at the denominator of our function over here, which would be 2 over x minus 4 equals 0. I would add 4 to both sides, and I get 2 over x equals 4. Multiply this side by x and that side by x to cancel it out, and I get 2 equals 4x. And then I'd want to divide by the number in front of x, so divide by 4, divide by 4. I end up with x is equal to 1/2 or 0.5. So that means that we can't have 1/2 in this problem either. So we'd mark 1/2 on the number line, cross it out. That means our domain is this section to the left of 0, between 0 and 1/2, and bigger than 1/2. So to write that, we would write negative infinity to 0, 0 to 1/2, and 1/2 to infinity, with u's between the sections. So this is our domain. Now again, we'd want to simplify this original fraction, so we'd multiply by x, multiply by x, multiply by x. That allows this to cancel out. We just don't like to have small fractions inside bigger fractions. So the top is 3x, and we'd have 2 minus 4x. We'll look at one more of these. So this again says f of g of x. So it tells me to start with f, so I'd write f, but where there's an x, I'm going to put parentheses. And then g of x is inside, so I take that and I put it inside. So let's talk about the domain. We start with the inside function, g of x, which is square root of x. And that tells us that the inside of that has to be greater than or equal to 0. So that's the first part we have. And if we think about that on a number line, this would be 0, and we want to be going bigger than it, including 0 because we said or equal to. Then we look at the denominator of our function that we're working with over here. And this has got a fraction, so we want that denominator to not equal 0. So we'll find out what makes it equal 0. We'll add 3 to both sides. I guess the square root of x is equal to 3. To get rid of the square root, we would square both sides. So we get x is equal to 9. So 9 causes a problem in this fraction. That means that we can't have, 9 would be over here, it means we'd have to cross out 9. So our domain would be between 0 and 9, and then 9 and bigger. So we would say that we can include 0 though, because that's what we had to begin with, was a bracket. So we have 0 to 9. We can't include 9, cannot include 9, because that's what makes the denominator equal to 0. And then 9 to infinity. That's why we crossed out that 9 there. We can't use the 9. This cannot be simplified, so that we would just leave it like it is. We wouldn't need these parentheses, really. We'd just leave it like that. Okay, in this problem, it wants us to find f of x and g of x. So g of x is the part that's inside. That's the part that's easiest to see. So we'd write x squared minus 3x plus 2 as g of x. Because again, if we had f of g of x, g of x is the part that's inside. So then to write f of x, we'd write what's left. We'd have a square root. And then in place of that part that we just wrote, that green part, we'd write just a plain old x. And that's our answer. We'll do one more here as an example. Again, we'd have f of g of x. G of x is the inside part, so we look for what's inside here. So we'd have f of x equals, and g of x equals. The inside part was x squared minus 6x plus 5. So that's what we write for g of x. And then if we write the rest of it without that part that we did in green, we'd have something to the 4th power. And what we put in place of that is just a plain old x. And that's our answer.